Welcome everyone. In today's video, we will solve the problem number 1 to 7 of exercise 2.4 of Higher Engineering Mathematics by B.S. Grewal. So let us start with the first problem. So in the problem number 1 to 5, we are given some matrices and we are asked to find the rank of these matrices. So we will convert these matrices into their row echelon form, and there we will count the number of non-zero rows to find the rank. So let us start with the first matrix. So let us apply these two operations. On R2, we apply R2 minus 2R1, and on R3 we apply R3 minus 3R1. So applying these two matrices, we get an equivalent matrix, that is 1, 4, 5. So when we multiply this row by 2, this becomes 2, 8 and 10. So now we subtract row 2 from this. 2 minus 2 is 0. 6 minus 8 is minus 2, and 8 minus 10 is again minus 2. Now for next operation, multiply the row 1 by 3. So this becomes 3, 12 and 15. Now subtract this row from the row number 3. So this is 0. 7 minus 12 is minus 5, and 22 minus 15 is 7. Now we apply this operation on row 2. That divide row 2 by minus 1 by 2. So we get this matrix. Now multiply row 2 by 5 and add in row 3. So the matrix get converted into this one. 0, 1, 1 and 0, 0, 12. So after dividing the row 3 by 12, we get this matrix. Now this matrix is in its row echelon form and it has 3 non-zero rows. So rank of this matrix is 3. Rank of the given matrix is equal to 3. For this matrix, again we do the same thing. Now just divide the row 2 by 3 first. This is 1, 3, 4, 3, 1, 3, 4, 1, 1, 3, 4, 1. Now subtract row 2 from row 3. This is 0, 0, 0 and 0, and then Subtract row 1 from row 2. So 0, 0, 0, 1, 0, 0, 0, and 0. Now this matrix has been reduced into its row echelon form and it has two non-zero rows. So rank of this matrix is 2. Next, let us look at this matrix. So we apply row 2 goes to row 2 minus 2r1, row 3 goes to row 3 minus 3r1, and row 4 goes to row 4 minus 6 row 1. So after applying these operations, we get 1, 2, 3, 0. Now, when we multiply the row 1 by 2, it becomes 2, 4, 6, and 0. And subtract it from row 2. This becomes 2 minus 2, 0. 4 minus 4, 0. 3 minus 6 is minus 3. And 2 minus 0 is 2. Next, we are applying this operation. Multiplying the first row by 3. This becomes 3, 6, 9, 0, and subtract it from row 3. It becomes 3 minus 3, 0, 2 minus 6, minus 4, 1 minus 9 is minus 8, and 3 minus 0 is 3. Now applying the last operation. Multiplying the row 1 by 6, it becomes 6, 12, 18, and 0, and subtracting it from row 4, it becomes 6 minus 6, 0, 8 minus 12 is minus 4, 7 minus 18 is minus 11, and 5 minus 0 is 5. Now just replace, just a minute. We are exchanging the row 2 and row 4. We get 1, 2, 3, 0, 0, minus 4, minus 11, and 5. Then 0, minus 4, minus 8, and 3. And then 0, 0, minus 3, and 2. Now subtract row 2 from row 3. Just a minute. So subtracting row 2 from row 3. 1, 2, 3, 0 becomes 0, minus 4, minus 11, 5, 0, minus 4, minus 4 is 0. This is minus 8 plus 11 is 3. And then 3 minus 5 is minus 2. 0, 0, minus 3, and 2. Then add row 3 in row 4. 0, 0, 3 minus 2, 0, 0, 0, and 0. Now divide the row 2 by minus 4 and divide the row 3 by 3. The matrix is reduced into this one. 0, 1, 11 by 4 minus 5 by 4, 0, 0, 1 minus 2 by 3, 0, 0, 0, and 0. Now this has 3 non-zero rows, so rank of this matrix is equal to 3. Next is rank of this matrix. Okay, just on row 4, apply row 4 minus row 3. It becomes 5, 6, 7, 8, 6, 7, 8, 9, 11, 12, 13, 14. Then 16 minus 11 is 5, 17 minus 12 is 5, 18 minus 13 is 5, and 19 minus 14 is again 5. Then on row 3, apply that row 3 minus row 2. This is 11 minus 6 is 5, 12 minus 7 is 5, 13 minus 8 is 5, 14 minus 9 is 5, 5, 5, 5, and 5. Then apply that row 2 minus row 1 on row 2, and on row 4 apply that row 4 minus row 3. After applying these two operations, we get this matrix. 6 minus 5 is 1, 7 minus 6 is 1, 8 minus 7 is 1, 9 minus 8 is 1. This is 5, 5, 5, 5. This is 0, 0, 0, and 0. On row 3, apply row 3 minus 5R2. We get 5, 6, 7, 8, 1, 1, 1, 1. This is 0, 0, 0, 0, 0, 0, 0, and 0. Now exchange row 1 and row 2. And apply row 2 minus 5 times row 1. 6 minus 5 is 1, 2, 3. And after this matrix has been reduced into its row echelon form, and in its row echelon form it has two non-zero rows, so rank of the matrix A is 2. Next is problem number 5. Okay, let us make some changes in this matrix. That on row 4, apply row 4 minus 3, row 3. On row 3, apply row 3 minus row 2. And on row 2, applies row 2 minus row 1. After making these changes, we get this matrix: 1 square, 2 square, 3 square, 4 square. This is 2 square minus 1 square, 3 square minus 2 square, 4 square minus 3 square, 5 square minus 4 square, 3 square minus 2 square, 4 square minus 3 square, 5 square minus 4 square, 6 square minus 5 square, 4 square minus 3 square, 5 square minus 4 square, 6 square minus 5 square, and 7 square minus 6 square. Now, except the first row, in all the other rows, every entry is of the form n square minus n minus 1 square. So basically this is n minus n minus 1 and n plus n minus 1. This is, so this is just 1 into 2n minus 1. So every entry, and this thing is just equal to 2n minus 1. So after solving each entry, after simplifying each entry, we get this is n and 2n minus 1. 2 into 2 minus 1. So 2 2s are 4 minus 1, 3. 3 2s are 6 minus 1, 5. 4 2s are 8 minus 1, 7. And 5 2s are 10 minus 1, 9. Then again 3 2s are 6 minus 1, 5. 4 2s are 8 minus 1, 7. 5 2s are 10 minus 1, 9. And 6 2s are 10 minus 1, 11. 4 2s are 8 minus 1, 7. Then 5 2s are 10 minus 1, 9. 6 2s are 12 minus 1, 11. And 7 2s are 14 minus 1, 13. So this matrix has been simplified. And this is 1, this is 4, this is 9, and this is 16. Now let us proceed like we have done in the previous problems. Now apply row 2 minus 3r1, row 3 minus 5r1, row 4 minus, so on row 2 apply row 2 minus 3 row 1, row 3 apply row 3 minus 5 row 1, and row 4 apply row 4 minus 7 times row 1. So this matrix becomes 1 4 9 16. This is 3 minus 3, no, multiply this row by 3, this becomes 3 12 27 and 40. Easy. Now, subtract this row from row 2. So this becomes 0. 5 minus 12 minus 7, 7 minus 27 minus 20, and 9 minus 48 minus 39. In row 2 we get, now multiply the row 1 by 5. This becomes 5, 20, 45 and 80. This becomes 5 minus 5, 0, 7 minus 20 minus 13, then 9 minus 45 is minus 36, and 11 minus 88 is minus 77. Then multiply the row 1 by 7. Okay, so we can make these things more simpler. Let us subtract row 2 from row 1, row 3 from row 2, and row 4 from row 3. So apply. First apply row 4, apply row 4 minus row 3, row 3 apply row 3 minus row 2, and row 2 apply row 2 minus row 1. This becomes 1, 4. After applying row 4 minus row 3, 7 minus 5 is 2, 9 minus 7, 2, 11 minus 9, 2, 13 minus 11, 2. 5 minus 3, 2, 7 minus 5, 2, 9 minus 7, 2, and 11 minus 9, 2. 3 minus 1, 2, 5 minus 4, 1, 7 minus 9, minus 2, and 9 minus 16 is minus 7. 1, 4, 9, 16. Okay, easy. Apply row 4 minus row 3. Row 4 minus row 3. Then row 3 minus row 2. And row 2 apply row 2 minus 2 row 1. This row becomes 0, 0, 0, 0. 2 minus 2, 0, 2 minus 1, 1, 2 plus 2, 4, and 2 plus 7, 9. Then this becomes 2 minus 2, 0, 1 minus 8, minus 7, minus 2, minus 18, minus 20, and minus 7, minus 32, minus 39. And first row is intact, 1, 4, 9, and 16. Now interchange row 2 and row 3. Multiply row 2 by 7 and add in row 3. And after applying this operation, we get 1, 4, 9, 16, 0, 1, 4, 9. This is 0, 0. This gets multiplied by 7. 28 minus 28, and this 9 get multiplied with 7. This is 63, and 63 minus 39 is 24. divide row 3 by 8. So we get this matrix 1, 4, 9, 16, 0, 1, 4, 9, 0, 0, 1, 3, 0, 0, 0 and 0. And as there are 3 non-zero rows, so rank of this matrix is 3. So in this problem, we are asked to find the values of P so that the rank of this matrix is 3. Let us try to find the rank of this matrix and we will see what happens. The matrix is given to be this one. Just we will proceed as we have done in the previous problems. On row 2, apply row 2 minus 4 times row 1. On row 3, apply row 3 minus p times row 1. And on row 4, apply row 4 minus 9 times row 1. After doing all these operations, after performing all these operations, we get this matrix 1, 1, minus 1, 0. Now when we multiply the row 1 by 4, it becomes 4, 4, minus 4, 0, and subtract from row 2, it becomes 0, 0, minus 3 plus 4, 1 and 1. Then multiply the row 1 by p, this becomes p, p, minus p and 0, and subtract from row 3, it becomes p minus p, 0, 2 minus p, 2 plus p and 2 minus 0, it's 2. Then multiply the row 1 by 9, it becomes minus 9 and 0, and subtract from row 4, it becomes 9 minus 9, 0, 9 minus 9, 0, p plus 9 and 3 minus 3, 3 minus 0 is 3. Now interchange the row 2 and row 3. Zero, 2 minus p, 1, 1, 0, 0, 1, 1 and 0, 0, p plus 9 and 3. Now as in the previous problems, I want to make this entry 1. To make this entry 1, I need to divide the row 2 by 2 minus p, but I don't know if 2 minus p is non-zero or 0. If 2 minus p is 0, then I cannot divide the row 2 by 2 minus p. So from here, I'll make two different cases. In one where 2 minus p is 0, and in second case where 2 minus p is not 0. So case 1. When 2 minus p is 0, that is p is equal to 2. So when p is equal to 2, then this matrix becomes 1, 1, minus 1, 0, 0, 0, 1 and 1, 0, 0, 1 and 1, 0, 0, 11 and 3. Now apply that Now, if this entry is 0 and all the entries beneath this entry are 0, then we try to make this entry 1, which is already 1, and the entries below it to be 0. To make these entries to 0, we apply that row 3 minus row 2 and apply row 4 minus 11 times row 2. So this matrix becomes 1 1 minus 1 0 0 0 1 1 0 0 0 and 0, and this becomes 0 0 0 and 3 minus 11 minus 8. And after dividing the row 4 by minus 8, I got this entry to be 1, and then interchange the last two rows, we get this entry to be 1 and this entry to be 0. Now it is in the row echelon form, and rank of this matrix is 3. So what we wanted to find, we wanted to find the values of p so that the rank of this matrix is 3. Now we have seen in this case 1, that is when p is equal to 2, the rank is 3. So p equal to 2 is the required value, but there may be some more values of p that makes the rank of this matrix 3. So to investigate those values, we investigate the case number 2 when p minus 2 is not equal to 0. Case 2, when p minus 2 or 2 minus p is not equal to 0. So when 2 minus p is not equal to 0, divide the row 2 by 2 minus p. Okay, we have make a mistake here. It was 2 minus p, 2 plus p and 2. 2 plus p and 2. This was. So when we have substituted p equal to 2, let us redo this problem from here. So this becomes when p equal to 2, this matrix becomes 1 minus 1 1 1 minus 1 0 0 0 4 2 0 0 1 1 0 0 11 and 3. Okay, now exchange row 2 and row 3. This becomes 1 1 minus 1 0 0 0 1 1 0 0 4 2 0 0 11 3. Now apply row 3 minus 4r2 and row 4 minus 11 row 2. This becomes 1 1 minus 1 0 0 0 1 1. This becomes 0 0 4 minus 4 0 and 2 minus 4 is minus 2, then 0 0 11 minus 0 is 11 and 3 minus 11 is minus 8. Now divide the row 3 by minus 2 and row 4 by minus 8. and this becomes 0 0 1 1 0 0 0 1 0 0 0 1. Now apply row 4 minus row 3. 1 1 minus 1 0 0 0 1 1 0 0 0 1 0 0 0 and 0. It has three non-zero rows, so rank of A is 3. So for P equal to 2, rank of A is 3. So 2 is a required value, but there may be some more values of P which makes the rank of this matrix 3. For investigate those values, let us check the case when 2 minus P is not equal to 0. When 2 minus P is not equal to 0, we can divide the row 2 by 2 minus P. So this matrix becomes this thing 1 1 minus 1 and 0. This becomes 0 0 2 plus P divided by 2 minus P and 2 divided by 2 minus P, then 0 0 1 1 0 0 P plus 9 and 3. Now to make this entry 0, we multiply the row 3 by P plus 9 and subtract it from row 4. One one minus 1 0 0 1 2 plus P by 2 minus P 2 by 2 minus P 0 0 1 1 and 0 0. This becomes 0 and 3 minus P plus 9. So this is minus P and 3 minus 9 minus 6. This is minus 3 minus 6. Now what do we want? We want that value of P for which the rank of this matrix is 2. Now rank of A, this matrix will be 3 if it has 3 non-zero rows. That is, this row must be 0. That is minus 3 minus 6 must be 0. Sorry, this is minus 3 minus P. It was 3 minus P minus 9. It was minus P minus 6. Minus P minus 6. If minus P minus 6 is equal to 0, that is P is equal to minus 6. So rank of A is 3 when P is equal to 2 and P is equal to minus 6. If P is equal to 2 or P is equal to minus 6. Next problem is use Gauss-Jordan method to find the inverse of the following matrices. Okay. So how we proceed this? We write this matrix A as A. So we can write it as 205 21 minus 1 0 2 1 and 5 2 minus 3 is equal to 1 0 0 0 1 0 0 0 1 multiplied by A. Now what do? We apply row elementary operations and try to convert this matrix into identity matrix. By doing so, this matrix will convert into some other matrix B and this matrix A will remain as it is. So this matrix B will be the inverse of the matrix A. So let us start. Okay, just apply the operation that row 3 minus 2 times row 1. This becomes 2, this row becomes 4, 2 and minus 2. So 4 minus 5 minus 4 is 1, 2 minus 2 is 0, minus 3 plus 2 is minus 1. This becomes 0, 2, 1, and this is 2, 1, minus 1. Now don't forget to apply these same operation on this identity matrix A. So apply that row 3 minus 2 are 1, 0, 0, 0, 1, 0, and 0 minus 2 minus 2, 0 minus 0 and 1. Okay. Now interchange row 1 and row 3. By interchanging these two rows, I get 1, 0, minus 1, 0, 2, 1, 2, 1, minus 1 is equal to minus 2, 0, 1, 0, 1, 0 and 1, 0, 0 into A. Now apply that row 3 minus 2R. This becomes 1, 0, minus 1, 0, 2, 1, and this is 2, 0, minus 2. So on R3 we are applying that R3 minus 2R. So 2 minus 2, 0, 1 minus 0, 1, minus 1 plus 2 is 1. Apply the same operation on this matrix. Minus 2, 0, 1, 0, 1, 0. Now multiply the row 1 by 2. This becomes minus 4, 0 and 2, and subtract it from row 3. 1 minus minus 4 is 5. This is 0, and 0 minus 2 is minus 2. Okay. Now interchange row 2 and row 3. 1, 0, minus 1, 0, 1, 1, 0, 2, 1. Minus 2, 0, 1, 5, 0, minus 2, 0, 1, 0. Now apply row 3 minus 2R2. 1, 0, minus 1, 0, 1, 1. This is 0. Then 2 minus 2, 0, and 1 minus 2 is minus 1. Then minus 2, 0, 1, 5, 0, minus 2. Then 0 minus 10 minus 10. 1 minus 2 is 1. Then this is 4. Now multiply the row 3 by minus 1. We get 1, 0, minus 1, 0, 1, 1, 0, 0, 1 is equal to minus 2, 0, 1, 5, 0, 2, 10, minus 1 and minus 4. you should check the calculations here. May some of calculation may be wrong here. Okay. Now to make these two entries 0, we apply row 2 minus row 1, row 3, and row 1 plus row 3. In second row, we are subtracting the row 3 from row 2, and in first row, we are applying the row 3. Row 3 remains intact. Then 0 plus 0 0, 1 plus 0 0, sorry, subtract 1 minus 0 0, 1 minus 1 0, and 1 plus 0 0, 0 plus 0 is 0, and minus 1, it was 1 here, and minus 1 plus 1 0, it was also 1 here. Row 3 remains intact, and 5 minus 10 is minus 5, 0 minus minus 1 is 1, 2 minus minus 4 is 6, then minus 2 plus 10 is 8, 0 plus 1 is minus 1, and 1 minus 4 is minus 3. So if the calculations were right, this is the inverse of the given matrix. So you must check the calculations here. I think next problems are the similar one. We need to find the inverse using elementary operations or using Gauss-Jordan method. So this is all with the first part of the exercise 2.4. In the next video, we will discuss the problem number 8 to 11 of exercise 2.4. Thank you everyone.